Welcome to another problem session, everybody. This is a question from the JEE exam 2024 in India for the advanced physics part. So we are on section 2, and in that section you have multiple choices like that, but you have to work them out to know they're right. Each one of them has to be worked out because each of them could be right or wrong. Can't just guess them around. Okay, so this is JEE 2024 Advanced Physics Paper 1. Okay, now this question is actually quite tricky and in a nice way. I like this question. So if you want to know there's an object here, and then there's a lens, but above the lens is another fluid, and then behind over here is a mirror which will reflect the light back. So you're just changing the phase by 180. Just light comes in, reflects back. It comes vertically, then hits vertically, goes vertically back. But if it's an angle, if it comes this way, it goes that way. But it just reflected on that. And there's no power for this because the radius curvature for this mirror is infinite. Okay, so one way to think about it is where would the image be formed? Well, if light comes in, let's look at one of the rays, okay, just for illustrative purpose, and then we will see what trick should work. So I'm going to take a very wide ray. It'll come in and it will not go straight, but it's going to refract a little bit at that surface. And over here you have another normal. So it's this angle, but it's going to because refraction index is larger here, probably, they don't give you reference, and there are different values you're supposed to try out. So this would this is a normal, and so it's going to be on the other side of the normal. So it's going to come out here, and then it's going to refract, and then it's going to come out like this, and then it's going to go through this lens part and then this lens part. So if you look at this ray, it's going through the lens part twice, right? And one reflection here. It's going through this, through the lens once, and then through this lens one time, and then reflection goes again. So you might say, imagine I let the ray go and I don't think about the reflection. Of course, reflection makes a difference here, but so it will go through this and then this, and then here has to go through that also. So it's almost like this kind of thing. And then in this structure, instead of image forming by reflection out there, image going to form somewhere here. So you can see I have a compound lens, and a compound lens, they're all stuck together. Then we could imagine them like a lens like this part put out over there. So you could say I have a lens like this, and it's like that, and then there is some kind of some air here, air gap. I put a tiny air gap, and then I have and then like that. and the object is sitting here, and as long as we know f1 and f2, we can use the effective focal length, or so the power. So 1 over the power of this that this ray will face will be power of 1 over f1 plus 1 over f2, and the mirror here plus 1 over infinity for the mirror. So we can completely ignore that when, 1 over f here, power will be like that, 1 over f. So we can think of this as effective focal length problem. So in this effective focal length problem, we need to figure out focal length of these two composite pieces, okay? For that, for f1, 1 over f1 will be refractive index of the fluid, refractive index of fluid, minus 1, and then this radius of curvature, and they will be negative, minus 1 over r plus minus 1 over r. So the both of them negative, so this is going to be nf minus 1 minus 2 over r, and 1 over f2 similarly is going to be n of the length, this material over here, we're going to call it nl, and it's going to be 1 over r plus 1 over r, and this is going to be nl minus 1, 2 over r. When you add these guys up, you can see this constant factor will cancel out. So 1 over f effective will simply be 2 nl minus nf over r. Nf is what we are calling n in these things, okay? So let's just call it n over here. And it says that 1 over p plus 1 over q, so this is the object distance, image distance, 1 over f effective, and they're equal to each other. So, and they're both h, and that just gives us 2 over h. So that gives us let's write over here. That gives us 2 over h. 2 over h is 1 over f effective, which is 2 nl minus n over r. So 2 cancels out, so h is just r over nl is 1.6, 1.6 minus n, and r is 9 centimeters. So 9, and just all of them in centimeters. Okay, so we're supposed to figure out plugging in n different values of n and see what h comes out. So when for h plug 1.42, so that will be h will be 9 over 0.18, and so this would be 0.02. That's 50, and this is correct. So this is okay. How about this guy? H equals to 9 over 0.15. So this is 0.05 and 3. So you have a 300 over 5 is 60. and this getting 65. This doesn't look right, right? So this would not be right. And so B, let's B, this would be 1.6 minus 1.359, and so 9 over 0.25. So that's going to be 36, and that's correct. So that's okay. And D is going to be 9 over 1.6 minus 1.48, 9 over 0.12. 0.04, so 300 over 4, so this is not that, so this doesn't work out. So somehow I thought this was 65, but it's not. Just check again. So we had a H equals to 9 over 1.6 minus 1.45. Oh yeah, it's not going to be that. So it's going to be 0.159, and let's call it 900, and this is 15, and so this is 60. So of course this is not it. Okay, so just we get A and B. Now A and B is the correct answers, and the two others are wrong. Okay, so there you have it. If you like this kind of explanation, you can check out my website at this physicsbootcamp.org, and I find that you have to type this www. Okay. All right. Take care. Bye. See you in another video.